Okay, week 5, distance learning, thanks to COVID. So this week we're going to transition away from conic sections, take a look at trig functions, trying to get you guys ready for pre-cal next year. So bear with me here. There are a lot of vocab words that you're going to see in these notes. There are 12 problems. We're also going to do these notes, so they're kind of going to be a little bit longer. But they're not difficult problems. They're just a lot of them. So we're going to see trigonometry, trigonometric ratio, trigonometric functions, sine, cosine, tangent, cosecant, secant, and cotangent, inverse sine, inverse cosine, inverse tangent, reciprocal functions, angle of elevation, angle of depression, standard position, initial side, terminal side, coterminal angles, radian, central angle, and arc length. Lots of new words to see today. So the first thing we're going to look at are the trigonometric functions in right triangles. So sine, cosine, tangent, those are your three common trig functions. The other three are just the reciprocal functions. That means that it just flips the fractions. So sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So what that means is that the opposite is going to be the side that is across the triangle from the angle you're looking at. The adjacent, so with cosine, tangent, secant, and cotangent, they all have adjacent in them. The adjacent is the other leg of the right triangle. It's the side that helps to form the angle that we're talking about. So whatever theta is, so in this case, theta is just marked as theta, the 3 is the adjacent side. So one easy thing to remember, to help you remember sine, cosine, and tangent at least, is called SOHCAHTOA. It's written out SOHCAHTOA. It just helps you to remember the fractions that go along with sine. So sine is opposite over hypotenuse, so it's SOH. So cosine is adjacent over hypotenuse, so it's CAH, CAH. And tangent is opposite over adjacent, so TOA, the opposite over adjacent part. So then the other guys are just those fractions flipped around. There's really no nice phrase for them. Also with SOHCAHTOA, there's also a little phrase to help remember SOHCAHTOA. If you can't remember that, it is that some old hippie caught another hippie tripping on acid. So now what we're going to do is actually use those 6 trig functions for angle G specifically here. So what we want to do is just write out the fractions. We're not going to do anything with the fractions. We are literally just going to write out the fractions. So for sine, remember our SOHCAHTOA. So remember, sine is opposite over hypotenuse. That's what the first part of SOHCAHTOA says. So sine is opposite over hypotenuse, which in this case, from angle G here, the opposite is 24. The hypotenuse is 40. And then our adjacent is the other side we haven't talked about yet, the 32. So now we just set up our fractions, and we'll simplify. We won't even simplify. We'll just leave them as they are. So 24 over 40, maybe 12 over 20, 6 over 10, or 3/4, or 3/5, I mean. But we're not going to simplify them. We're just going to leave them as is. For cosine, these are all of G. I forgot to put G in there. It's adjacent over hypotenuse. And that's the 32 over 40. And then we have tangent of angle G, which is going to be the TOA part of SOHCAHTOA. So it's opposite over adjacent. And that is just going to be 24 over 32. Now, we need to take a look at the reciprocal functions. Those are going to be the cosecant, secant, and tangent. So what I like to do to remember these ones and how they match up, so cosecant has the co in it, which means it matches up with sine. So it's opposite. So the secant doesn't have co in front of it, and it goes with cosine. So cosecant is first. It is abbreviated CSC, and it goes along with sine. So it's going to be the hypotenuse over the opposite, which just takes what sine's fraction is and flips it. So 40 over 24. Same thing with cosine and secant. Just takes that adjacent over hypotenuse fraction and flips it. So hypotenuse over adjacent, which makes it 40 over 32. And cotangent, our last one. Cotangent is the opposite of tangent. Those two are the only two that keep the same name kind of with them. I don't know how to explain it like that. But it still flips tangent, so it's adjacent over opposite. And that's just going to be 32 over 24. And there is our 6 trig functions evaluated. We're not going to do anything more with them. We could simplify all these fractions because everything's even, and really everything's divisible by 4. So let's take a look at our next one. So same idea here. This time, though, we're missing what our hypotenuse is, but we do know what the other two sides of our triangle are. So what we want to do, we could go ahead and find those using Pythagorean theorem. Or we can go ahead and kind of just start using C as it is and leaving it there, but probably want to just go ahead and use Pythagorean theorem to find out what C is. So to find C using Pythagorean theorem, I'm going to go ahead and just solve it for C, and that's going to be 5 squared plus 3 squared, which is going to be the square root of 25 plus 9, or the square root of 34. I'm just going to leave it as the square root of 34. Again, we're not trying to break things down. Plus, that doesn't really break down besides 2 and square root of, or 2 and 17. So those are both primes, so that's not going to go anywhere. So square root of 34 is fine how it is. So we'll relabel C as the square root of 34. And now we're ready to go ahead and do our trig functions, remembering SOHCAHTOA. So sine, and this is for angle A. It's going to be the opposite, or the 5. Our adjacent is our 3, and the hypotenuse is what we just found, our square root of 34. So that's going to be, again, opposite over hypotenuse, which is 5 over the square root of 34. Now, in mathematics, there's rules here, and we can't leave a square root on the denominator of a fraction. So we have to multiply this. The easiest way to do that is just to multiply by the square root of 34 over the square root of 34. That will get rid of the square root on the bottom, leaving us with just 34. And unfortunately, we have kind of an ugly number, but it is 5 square root 34 over 34. Sorry for the noise there. My dog is old and doesn't like to walk a certain way to go to her water bowl. So cosine of A is going to be our adjacent over hypotenuse. So that's going to be the 3 over square root 34. And once again, we have to get rid of that square root of 34 in the denominator. So square root of 34 over square root 34. And it's just 3 square root 34 over 34. So tangent is already given to us. It doesn't say we have to find it. We just have to find the other 5. So we're not going to do tangent. We're just going to skip over now to our other 3 and do cosecant, secant, and cotangent. So cosecant we know is the opposite of sine, so that's going to be hypotenuse over opposite, or the square root of 34 over 5. Didn't get our hypotenuse on the bottom, or square root on the denominator this time, so we're good. We don't have to do anything else. Our secant is going to be the hypotenuse over adjacent. And once again, we're going to get that square root of 34 on top, this time over 3. I'm perfectly fine with that too. And then cotangent is not even going to bring that in. And we already know that tangent is 5/3, so cotangent is 3/5. There we go. And that's that one. Now we found the other 5 trig functions for angle A. So here there are our special right triangles. We haven't really talked about them in this class, but hopefully you got to learn something about them in geometry if you've taken it already. I almost said tooken. If you've taken it already. So there's just some special things that happen with those specific angles. So sine of 30 is 1/2. Cosine, because it's the opposite direction, is of 60 is 1/2. Cosine of 30 and sine of 60 are both square root 3/2. And then tangent of 30 is square root 3/3. The reason that happened is because it ends up being 1 over the square root of 3. Again, you have to multiply by square root 3/3, and it ends up being square root 3 over square root 3. The answer ends up being square root 3/3. Tangent of 60 is just square root 3/1, which is just square root of 3. For the 45, 45, 90 triangles, for sine of 45, it's square root of 2/2. Same thing with cosine of 45. Tangent of 45 is 1. These 9 things are always the same. So if you can get something down to being the sine of 30 or the tangent of 45, you can plug this number in every time and you know that you're good. That's the right number. It's never going to change unless there's a number out front. Then it's not the same thing anymore. It's being multiplied by some factor. So here we have a 30, 60, 90 triangle. It only shows us the 60, but we know that they add up to be 180. So if it was a 90-degree angle and a 60, then the other one's got to be 30. So we need to use a trig function to find the value of x. So we don't know what x is, but we do know that it is the opposite to the 60. So we really didn't even need to know about the 30. So this is the opposite, and the hypotenuse given to us. So if we look at SOHCAHTOA, we need to figure out which one has the opposite and hypotenuse, the O and the H. So it's sine. So we're going to do the sine of 60 is equal to x over 12. Well, the slide we just looked at told us that the sine of 60 is the square root of 3/2. So now, all we have to do is just multiply this out, or cross multiply it. So you cross multiply, we get 2x equal to 12 square root 3, and we divide both sides by 2. And x is equal to 6 square root 3. It does say to round to the nearest tenth if necessary, so at this point we can go ahead and just plug it in the calculator and get it. Now, granted, we could have just multiplied both sides by 12 as well, but because we know it's sine of 60, it makes it a little bit easier. We don't have to worry about a calculator giving us a wrong answer because it's in the wrong mode or something. We know that the sine of 60 is square root 3/2. Plug that in instead, cross multiply, solve for x. And that comes out to be about 10.4. No units here, so that's it. So here we have Joel looking at this building. He walked 200 feet from the base of a building and used an inclinometer, it's a hard one to say, to measure the angle from his eye to the top of the building. If Joel's eye level is 6 feet, what is the distance from the top of the building to Joel's eye? So really, that extra little info about how tall Joel is has nothing to do with anything. We know how far away he is. We want to know how far his eye is from the top of the building. Then we just need to find the hypotenuse of the triangle pictured here. So we have our angle. We have the adjacent side to it. We are looking for the hypotenuse of it. So again, SOHCAHTOA, I'm going to write it up top here. We have the adjacent side. And we have the hypotenuse. Oops, I wrote it swa instead of so. I was wondering why I had so many things underlined. Ka, toa. There we go. So again, we have adjacent side and hypotenuse. The only thing with two lines under it is the ka. So we are using cosine. So cosine of 76, that's not one we know easily, right? But that's okay. And then 200 over our hypotenuse of d that we're trying to find. So at this point, we are lacking on having the ability to just use one of our little cheats that we had for a special right triangle. We don't have one. So instead, we are going to have to rely on our calculator. And that means you have to make sure your calculator is in the right mode. If it is not in degree mode, then you're going to get the wrong answer. If it says radians, we haven't talked about radians yet, so you're going to get the wrong answer if it's in radians. Make sure it says degree mode. Desmos can do that as well. TI calculators can do that. Your phone calculators can do that. You have to make sure that they are in the correct mode. So now at this point, so there's technically a two-step process. You multiply both sides by d, and then you divide by the cosine of 76. I hate having to do two steps when I can only do one, when I can do just one, right? So whenever you're trying to solve for the denominator of a fraction, and that's all you have on one side of the equal sign, switch what's on either side. It's going to make your life a little bit easier so you don't have to do two steps. So you have the distance d equal to 200 over cosine of 76. That we can plug in the calculator. 200 divided by cosine of 76, and it doesn't say where to round here, so we'll just round to the nearest tenth still, is 26, sorry, put 7 in the wrong spot, 0.7 feet. So now the inverse trig function. So we've looked at the reciprocal and the standard three. The inverse ones are what you would use if you don't know what the angle is. So if you're working the other way around, it's kind of like the subtraction to addition, or the division to multiplication. They're the opposite function. So inverse sine would be used to find the angle if you're given the opposite and hypotenuse. Inverse cosine would be used to find the angle if you are given the adjacent and hypotenuse, and tangent, the inverse of it, would be used to find the angle if you're given the two legs. So that's what we're going to do here. We're going to find our two angles that are missing for our triangle. We do know one's 90, right? It's a right triangle still. But we need to find our two angles. So we're looking at A and B. So I'm just going to use, we can either just use sine, we could use sine and cosine, and really, it doesn't really matter. We can use tangent. We can use any of the three that we have. We could even use, we haven't talked about these, but there's inverse of the reciprocal functions as well, but we're not going to do those. So if we're looking for A, let's do sine. So this is going to be the opposite and the hypotenuse. So for A, we're going to use sine of A is equal to 9 over 17. So if we're going to use our inverse sine to find A, we now need to do that. So A is going to be equal to the inverse sine of 9 over 17. Again, make sure your calculator is in degree mode. If not, it will give you an answer here. It will give you an answer in radians, though. And it's going to be a decimal. And again, we haven't seen radians yet, so you're going to be very confused. So this comes out to be a nice, simple, I think that says 32.0 degrees. Rounded up to 32 even. Now, technically, because we got 32.0, we could just subtract that from 90 and we'll get our answer for B. But we're not going to do that. We want to use trig functions. So we are going to instead use cosine. So this for B is the adjacent and still the hypotenuse. So we're going to use the exact same fraction for cosine now to find angle B, which is going to be 9 over 17 still. And again, we just do our inverse cosine. So B is equal to the inverse cosine of 9 over 17. And again, making sure our calculator is in the right mode, we do get 58.0 when we round to the nearest tenth. I wish this went to further decimals, because it's not exactly 58.0. It's not 58. It's 58.02 or something like that. So that's fine. Or it's 57.98, something like that. I can't remember exactly what the decimals were. I calculated these a while ago. All right, so let's take a look at number 6. Moving along. We're already at 20 minutes here, and we're only on number 6. So here we are looking at elevation and depression angles. So now a golfer is standing at a tee looking up at a green on a hill. The tee is 36 yards lower than the green, and the angle of elevation from the tee to the hole is 12 degrees. From a camera in a blimp, the apparent distance between the golfer and the hole is the horizontal distance. So we want to find that. Now, I'm going to tell you this, but it's not always the same. For every or most elevation and depression problems, the angle or the trig function you're going to use is going to be tangent. It's not always true. Sometimes you will want to find the hypotenuse, or you'll be given the hypotenuse, but most commonly it's tangent. So here we are just looking for this distance down at the bottom. So again, we're going to use tangent. So tangent of 12 is equal to 36 over d. And using my little swap it out tool or trick, just 36 over the tangent of 12. And our distance is 169 doesn't say word around on this one, so 67 yards. Same idea here. This one's an angle of depression instead of elevation now. The hill on a roller coaster has an angle of descent or an angle of depression of 60 degrees. Its vertical drop is 195 feet from a blimp. The apparent distance traveled by the roller coaster is the horizontal distance from the top of the hill to the bottom. We want to find that distance. So again, we're finding x at the top of our picture. So that is the other leg of our triangle. So we are going to use tangent. This time it's 60 degrees. And that's equal to 195 over x. Now, we need to remember back to our little sheet about our 30, 60, 90 right triangles. Tangent of 60 is just equal to the square root of 3. So instead of having to worry about our tangent of 60, that's the square root of 3 over, or equal to 195 over x, or x equal to 195 over the square root of 3. Now again, we're going to have to use a calculator, or if you want to leave it without rounding, you can just multiply by square root 3 over square root 3. Be 195 square root 3 over 3, and simplify from there if you can. But we're going to go and plug in the calculator and get our rounded decimal, 112.58 feet. So angle measures. So now we're going to take a look at something a little bit different. If the measure of an angle is positive, the terminal side is rotated counterclockwise. So the way this works, rotation about the origin is from the x-axis counterclockwise, so the opposite of a clock. That's positive. If it's going the other way, it's negative. So here what we want to do is actually draw roughly what those angles are. So 210 degrees is just past 180, right? 180 would be halfway around. So this is 180. But we want to go further than that, 30 more degrees. So that's about there. Sorry, I got an email there. And then for the second one, so that's all we have to do for that. We're just drawing it. And for the second one, for part B, it's negative 45. So we're going to go the other way. And 45 is just halfway. As halfway as I can draw it, that is. And there it is. Pretty simple to do those. This next one is a springboard diving competition. Diver made a 900-degree rotation before slicing into the water. We want to draw the standard position for 900 degrees. So that, remember, one rotation is 360. 900 is a lot more than that. So we would go 90. So basically, remember, that's 90, right? So we do that 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's your 900-degree angle. A spiral. Number 10, we want to find an angle that has a positive measure and an angle with a negative measure that are coterminal. So coterminal means that the line that we draw for our rotation is the same line. So it ends at the same spot. So 210 degrees, really all this is asking us to do is add 360 to it and subtract 360 from it. So this first one, if we add, so 210 plus 360, that's going to give us a full rotation back around to the 210, and that's going to get us 570. And then we go the other way, 210 minus 360. That's going to give us a negative number, which is what we want, because we want the negative coterminal side too, and that's 150. For the other one, same idea, negative 120 plus 360. 360 is bigger than negative 120, or 120, so it's going to bring us back to positive. And that's going to be 240 degrees. Sorry, my dog started barking there. I had to pause for a second. So back to this one, negative 120 minus 360. It's just going to make it go further counterclockwise and get us a negative 480. And there we go. We got a positive and negative that are coterminal with the angles that we're given. So now we're going to take a look at that radians thing, right? So degrees and radians are two different measures for the same thing, angles. Just like feet and meters. They're just different units for the same kind of thing. Same thing you're measuring. So here we want to convert these to their opposites. So the first one's 30 degrees. We want to convert it to radians. So if you think about it in terms of like dimensional analysis in chemistry class, you're going to try to multiply across by what you want to keep and divide by what you want to get rid of. So here we have degrees. We know that pi, sorry, the last slide showed it. I should have talked about it, but pi is 180 degrees in rotation. So, or 180 degrees in radians. So pi radians is 180 degrees. So that's our conversion factor. So we're going to multiply this by 180 degrees on the bottom and pi radians on the top. So we multiply across, we get 30 pi over 180. You get rid of that 0. And 3 over 18 is 1/6, so it's pi over 6. Now the next one, we're going the other way. So we're going to do the same thing though. So pi radians over, or with 180 on top, degrees. The radians are going to cancel. So that is going to be 5 times 180. But actually, let's simplify first. Sorry, I forgot. So the 3 and the 180 can simplify because 3 goes into 180 a nice even 60 times. So that's 1 and 60 degrees. So now multiplying across is a little bit easier. And the pi's are also going to cancel, by the way. So those two pi's are gone. So the denominator is just 1 on the bottom. The top is a negative 5 times 60. Negative 5 times 6 is negative 30, so this would be negative 300 degrees. So now, this is what is called the unit circle. This is kind of a cheat sheet guide to know how to go from radians to degrees for various angles. It's all positive though, so if you have a negative angle, you kind of have to just work your way backwards or just go the same direction but keep in mind it's negative. So it's just showing you the same degrees for 60, or same measures for 60 degrees, and radians is pi over 3. So the way I like to remember those two is that the numbers flip, right? So 60 degrees is pi over 3, 30 degrees is pi over 6, 45 is pi over 4. The 4 stays with it. And then you just add on more as you go. So once you get to 90, it's pi over 2, but technically that's going to be also the same thing as if you had 3 pi over 6, right? Because that would simplify to be pi over 2. Same thing with 2 pi over 4. That is also 90 degrees, and that simplifies to pi over 2. 180. And then arc length there, that's what we're going to look at for the next problem, is just another equation for arc length. So in geometry, it's different because you're looking at it in terms of a geometry problem, right? You haven't learned radians yet, so you're just thinking of it as far as how much of the circle wedge it is using, or just the circumference of the circle. Now we're looking at it in terms of the radius and the angle that it's forming. So you just multiply those two together, but it gives it to you in radians, so you have to be careful with it because it will be a different situation. Or your angle has to be in radians, that's what it is. So here, the steering wheel of a monster truck has a radius of 11 inches. How far does the point on the steering wheel travel if the wheel makes 4/5 of a rotation? So we know that the 4/5 is our rotation, and that's of 360. So we need to multiply this out to figure out what angle we're talking about. That way we can, well, actually we want to multiply it by 2 pi. Sorry. We want it in radians, right? Because the formula we're going to use for it is r theta, and theta has to be in radians. Otherwise you'll get a very, very large number that doesn't make sense. So we need to multiply this by 2 pi, which means 4 times 2 is 8, 8/5, 8 pi over 5. We can leave it just like that, that's fine. Because we're going to multiply by 11. So that'd be 88 pi over 5. Or 17.6 pi. And it doesn't tell us how to round it, but we'll go ahead and round it to the nearest thousandth because that's what I like to do. So 55.292 inches. There you go. And that's it for our notes. We'll see you next time.